Hello friends, welcome back to my channel Maths by Samit Deshmukh. So in this video we are going to prove one of the very important formulas from this chapter, which is called as factorization, and later on we will prove defactorization formulas also. In this chapter we have studied many new formulas, which first we have proved compound angle formulas. So we have discussed about 8 formulas: sin A plus B, sin A minus B, cos A plus B, cos A minus B, tan A plus B, tan A minus B, cot A plus B, and cot A minus B. Later on we have constructed one table of allied angle formulas, and then what? Half angle, double angle, triple angle formulas. And applying these formulas we have solved example also. Now let us try to prove the factorization formulas. So if you are new on my channel, subscribe the channel and hit the bell icon to get the notification of every newly uploaded videos. So in this case we are going to prove that value of sin C plus D is equal to 2 sin C plus D upon 2 into cos C minus D upon 2. If you'll observe the left hand side very carefully, two terms are connected either by plus or by what? Minus, and we are converting the sum or difference in terms of what? Product. Product means what? In terms of factor. That's why these formulas are called as factorization formulas. So to prove these formulas we are making the use of compound angle formulas. So already we have proved this formula. Just once again revise the value of sin A plus B. Sin A plus B is equal to sin A into cos B plus cos A into sin B. What is the value of sin A minus B? Sin A minus B is equal to sin A into cos B minus cos A into sin B. Then write down the formula of cos A plus B, which is equal to cos A into cos B minus sin A into sin B. And lastly we are writing the formula of cos A minus B, which is equal to cos A into cos B plus sin A into sin B. So already we have proved these formulas in the first part of this chapter. Let us denote first formula by equation first, second formula by equation second. In the same way, third and fourth formula by equation 3 and equation number 4. Now we are taking addition of equation first and second. Let us see what we'll get if we are adding these two equations. So add equation or adding equation first and second, we get first and second we get. Let us see what we'll get. On the left hand side, if we are taking the addition of these two equations, what we will get here? Sin A plus B plus sin A minus B, isn't it? Simply we are taking addition, first addition of what? Left hand side. Now we are taking addition of right hand side. Observe the first two terms, sin A into cos B plus sin A into cos B will be equal to twice sin A into cos B, twice sin A into cos B, and addition of these two terms, cos A into sin B minus cos A into sin B, will get what? Cancel. Means this result we are getting if we are taking addition of equation first and equation second. Now we are taking difference of equation second and first, means from difference of equation first and second, means from equation number first we are subtracting equation number second. So here we are writing then subtract equation second from first. Let us see what we will get if we are taking this subtraction, means we are subtracting the second equation from first. So what we'll get on this side if we are taking subtraction? So we will get here sin A plus B minus sin A minus B. Now let us see what we are getting on this side if we are taking the subtraction. We are subtracting equation second from first, means here we will get minus, and here minus into minus what we will get? Plus, if we are taking this subtraction. So sin A into cos B minus sin A into cos B, means these two terms will get cancelled, and here cos A into sin B plus cos A into sin B will become twice cos A into sin B. So on this side we will get twice cos A into sin B. So whatever may be the new equation we have got here, denoted by equation 5 and this by equation number 6. Now we are taking addition of these two equations, means equation third and fourth. Let us see what we'll get. Adding equation third and fourth, adding equation third and fourth, we get On the left hand side, see what we'll get. Cos A plus B plus cos A minus B. So cos A plus B plus cos A minus B is equal to, now observe the addition of right hand side. On this side, cos A into cos B plus cos A into cos B will be twice cos A into cos B, and here we can observe that minus sin A into sin B plus sin A into sin B will get cancelled. Means on this side, what addition we are getting? 2 cos A into cos B. Let us denote this new equation by equation number what? 7. Now we are subtracting equation number 4 from equation number 3. So subtract equation 4th from 3rd. Let us see what we will get after taking this subtraction. On this side, what we will get? Cos A plus B minus cos A minus B. Cos A plus B minus cos A minus B. Observe the subtraction on right hand side very carefully. We are subtracting this equation from equation number 3rd. So here we will get minus, and here also we will get what? Minus. So these two terms will get cancelled. Cos plus cos A into cos B and minus cos A into cos B will get cancelled. And here minus sin A into sin B and minus sin A into sin B will become what? Minus twice sin A into sin B. Minus twice sin A into sin B. If we are taking subtraction of, we are subtracting equation 4th from equation number 3rd, we will get this result. And this new equation, let us denote it by equation number 8. Now once these equations are known to us, this equation number 5, 6, 7 and what? 8. At that time, we will focus on our required result. What is our first formula? Sin C plus sin D. Means, if you will observe equation number 5, if we are able to replace A plus B by what? C and A minus B by what? D. So, we will get our left hand side, sin C plus sin D. Means to get this left hand side, just simply we have to denote A plus B by C and A minus B by what? D. So let us see what we will get if we are using, if we are denoting A plus B by C and A minus B by D. So let here A plus B is equals to, I am denoting this A plus B by what? C, and A minus B I am denoting by D. Once these two values are known to us, now focus on our right hand side. What is the first angle on this right hand side? We will require the value of C plus D upon 2 and the value of C minus D upon 2. So let us try to find out value of C plus D upon 2 and C minus D upon 2. C is also known to us and D is also known to us. So therefore C plus D upon 2 will be equal to. So I am first substituting the value of C. C is equal to A plus B plus D is equals to A minus B upon 2, keep it as it is. So in the denominator 2, keep it as it is. Observe the numerator very carefully. Here A plus A will be equal to 2A and plus B and minus B will get cancelled. After cancelling 2, what we will get? A. Now we are able to replace this A by what? C plus D upon 2. Already 2 is there, and here value of A means what? C plus D upon 2. Let us check what is the value of C minus D upon 2. And C minus D upon 2 will be equal to, replace C by its value. What is our supposition? C means A plus B. A plus B minus D. This D means what? A minus B. A minus B. In the denominator 2, keep it as it is. Let us try to find out difference of these two bracket. Better way, orally also we are able to find out difference. Observe the difference very carefully. This plus A and minus into A means minus A will get cancelled. Plus A and minus A will get cancelled. And B minus minus means plus B. B plus B will be equal to 2B. In the denominator 2, keep it as it is. After cancelling 2 from numerator and denominator, what we will get here? B. Now, if we are substituting these values in equation number 5, 6, 7 and 8, I think we will get our required result. Observe the equation number 5. If we are replacing A plus B by C, so we will get sin C. Again, A minus B by what? D. So here we will get plus plus sine d, means on this side this is c and this is d, means what we are getting on the left hand side, sine c plus sine d, and on the right hand side, to keep it as it is, a can be replaced by what, c plus d by 2, and b can be replaced by what, c minus d upon 2, so that we will get our required right hand side also. Means if we are substituting these values in equation 5, 6, 7 and 8, we will get our required result. So that's why here we are writing that put put a plus b is equal to c, a minus b is equals to d. Again a is equals to c plus d upon 2, and b is equals to c minus d upon 2 in equation 5, 6, 7 and 8 we get. Let us see what result we will get if we are substituting these values in this equation. So first we are substituting these values in equation number 5. So here a plus b can be replaced by what, just already we have seen a plus b can be replaced by c, a minus b can be replaced by what, d. So on this side we will get sine c plus sine d. To keep it as it is, sine also as it is, this a can get replaced by what, c plus d upon 2, and b can get replaced by c minus d upon 2. So replace a by c plus d upon 2 and b by c minus d upon 2, we will get this our first required result. Now if we are substituting these values in equation number 6, in which equation 6? So here a plus b will get replaced by c and a minus b will get replaced by d. So on this side we will get sine c minus sine d, sine c minus sine d. Let us check whether we are getting our required result on right hand side or not. So to keep it as it is, again already we have seen that a will get replaced by c plus d upon 2 and b will get replaced by c minus d upon 2. So here we will get c plus d upon 2 and here we will get c minus d upon 2. Means what result we are getting on the right hand side? 2 cos c plus d upon 2 into sine c minus d upon 2, which is nothing but required result in the formula number 2. Now if we are substituting these values in equation number 7, so this is equation number 7. So here a plus b will get replaced by what, c, and a minus b will get replaced by d. So here we will get sine c cos c plus cos d, means we are getting left hand side of formula number 3rd. On the right hand side, to keep it as it is, cos also as it is. Observe that cos as it is, a will get replaced by c plus d upon 2 and b I am replacing by c minus d upon 2. So we will get 2 cos c plus d upon 2 into cos c minus d upon 2, which is nothing but right hand side of formula number 3rd. Means if we are substituting these values in equation number 7, we will get the proof of third formula. And lastly, we are substituting all these values in equation number 8. So see here, this is equation number 8. A plus b means c and a minus b means d. So on the left hand side we will get cos c minus cos d, which is nothing but our left hand side of fourth formula. And on the right hand side, minus 2, keep it as it is. And just now we have seen that a means what, c plus d upon 2, and b means what, c minus d upon 2. So minus 2 sine c plus d upon 2 into sine c minus d upon 2. So we will get the proof of this fourth formula. Now we are simplifying this fourth formula. Just I am replacing minus. So keep the first term as it is, 2 also as it is. Just simply I have replaced minus. Minus will get replaced by this formula. If you want, give a reason also. Sine minus theta will be equal to what? Minus sine theta. So means this minus can be written as minus sine theta, can be written as sine minus theta. So here also minus sine theta can be written as sine minus theta. यानी ये माइनस हम एंगल में ले रहे हैं, and if we are taking this minus into angle, it will get multiplied to this angle. What is the angle here? C minus d upon 2. So if we are multiplying to it by minus, it will become C minus d will become what? D minus C upon 2. Means simply minus sine theta can be written as sine minus theta. But if I am multiplying here by minus, C minus d will become what? D minus C. Means you are able to remember first formula also or second formula also. But if C is greater than D, then use first formula. If D is greater, then use second formula. We will have two choices. Apply any one of these two formulas. In this way, we have proved factorization formulas. So hope the idea about factorization formulas are very clear to you, and hope the idea that why we will call it as factorization formulas is also very clear to you, because we are converting sum and difference into what? Product. And product of the terms means what? We are finding factors of that expression, factor of this expression, and that's why these formulas are called as what? Factorization formulas. In this way we have proved the important factorization formulas. Now let us try to prove defactorization formulas. Now see, in case of factorization formulas, what we have seen, convert sum and difference into what? Factors. Now we are discussing defactorization formulas. In case of defactorization formulas, we are converting factors. These are what? Multiplication means what? Factors. Factor in terms of what? Sum and difference, and that's why these formulas are called as defactorization. In case of factorization, convert sum and difference into factor. In case of defactorization, convert factors into sum and difference, isn't it? So well, the proof of defactorization formulas is already we have proved in what? Factorization formula, means we have to just copy the proof of factorization formulas. So let us revise what we have seen in case of factorization formulas. We have written these four formulas: sin a plus b is equal to sin a into cos b plus cos a into sin b, sin a minus b is equal to sin a into cos b minus cos a into sin b, then cos a plus b is equal to cos a into cos b minus sin a into sin b, and cos a minus b is equal to cos a plus cos a into cos b plus sin a into sin b. Later on, what we have taken addition of these two equations. In case of addition, on this side we will get addition of these two terms, and on this side these two terms will get cancelled since their sign are different, and addition of these two terms is 2 sin a into cos b plus sin a into cos b is 2 sin a into cos b. This whole part we have discussed in the proof of factorization also. But if you observe here equation number 5 very carefully, what is the value of 2 sin a into cos b? Value of 2 sin a into cos b is equal to sin a plus b plus sin a minus b, and which is nothing but our first formula. Observe that 2 sin a into cos b. Is it our left hand side? Yes, 2 sin a into cos b is equals to what? We have to show that its value is equal to sin a plus b plus sin a minus b. Observe that same expression is there, sin a plus b plus sin a minus b, means this equation number 5 is nothing but our first defactorization formula. Now later on we have taken subtraction of these two equations. We have subtracted equation second from first. We have got this result. On this side we have taken this difference, and on this side if we are taking difference, these two terms will get cancelled, and here on this side we will get 2 cos a into sin b, and 2 cos a into sin b is equal to sin a plus b minus sin a minus b is nothing but our second defactorization formula, 2 cos a into sin b. Is it our left hand side? Yes, is equal to sin a plus b minus sin a minus b, sin a plus b minus sin a minus b. So in this way we have proved the second defactorization formula. Observe the third one. What is third? 2 cos a into cos b is equal to cos a plus b plus cos a minus b. Cos a plus b and cos a minus b is known to us. Just simply, if you observe this side, we have to take the addition of these two equations, which already we have taken addition of these two equations. And after taking addition of right hand side, what result? These two terms will get cancelled, and addition of these two terms is 2 cos a into cos b. And this is nothing but our third defactorization formula, 2 cos a into cos b. Check that. Is it the one of our side, 2 cos a into cos b, and we have to prove that its value is equal to cos a plus b plus cos a minus b. So in this way we have proved the third formula also. But now observe the fourth formula. Later on we have taken subtraction of these two equations. Observe, we have taken subtraction, and what result we have got here? Minus 2 sin a into sin b. So but here minus is not there, means we have to replace this minus. To replace this minus, simply we have to multiply both sides by minus. So if I am multiplying to right hand side by minus, so this minus into minus will become plus. So we will get 2 sin a into sin b, and on this side if I am multiplying by minus, this negative term will become positive. So cos a minus b, this is what? Negative term, which will become positive. And if I am multiplying by minus, positive term will become negative, means what will get? Minus cos a plus b, and check that is it our last required formula. What is the last formula? 2 sin a into sin b. Yes, we have got 2 sin a into sin b, and we have to show that its value is equal to what? Cos a minus b minus cos a plus b. In this way we have got the proof of defactorization formulas also. Now we have proved maximum formulas from trigonometry. Only the last part of this chapter is trigonometric function of angles of a triangle. Means maximum formulas we have introduced. Using these formulas, now you are able to start the syllabus of class 12th also. Already the videos of trigonometric function of class 12th are uploaded, so you are able to watch those videos also, so that this whole unit trigonometry will get clear to you and you are able to solve the objective type question also. So well, in the next video we are starting exercise on factorization and defactorization formula, next exercise from this chapter. If you think that these videos are helpful to you, so please like the videos and share these videos with your friends also.